In this video, we are going to look at tips to increasing productivity for scripting in Unity. Using namespaces in Unity comes with several benefits. It makes it easier to organize code, avoid naming conflicts, it helps facilitate encapsulation and modularity, and with that also improves code reusability, testing, and readability. To easily add a root namespace, go to Edit, Project Settings, Editor, and add a root namespace. Now when creating a new script, the namespace is automatically added. You can also edit the script templates themselves, including adding a namespace and much more. First, delete out the root namespace in the project settings to ensure you don't end up with two sets of namespaces. Script templates are stored in a specific folder on either Windows or Mac. Make a copy of the script templates folder. Now you can drag this folder into the Unity project window. Close and restart Unity, and now it will be using the templates in this folder instead of the originals. Open the first file, which is the default script template. Here you can add a namespace to protect your scripts. Now remove any unnecessary comments and modify it in any way you like. For example, you could remove the start and update methods, or add awake and disable methods, or any other combination. New scripts will now use this updated template, and you can change the template layout numerous times throughout the project. Attributes are metadata markers that provide additional information or behavior to classes, fields, methods, and other elements within Unity scripts. Now you probably already know tooltip and serialize field, but there are several more available. This script requires a character controller to be attached to an object, so we can use the require component attribute to achieve this. Now when I drag this script onto an object, it automatically adds the character controller component. It also prevents anyone from removing that required component and reduces the chances of errors when a script needs to communicate with a component type. There is also a help button on all script components. By default, this will take you to the Unity documentation. However, we can customize this to open any URL. Using the help URL attribute, I can paste a URL here, and the help button now directly links to that web page. This can be useful for sharing a workflow, directions, or instructions from a web page or a YouTube video. You can also customize the inspector using attributes such as header to create a heading and range attribute to restrict a float variable within a certain range. Now in the inspector this looks much clearer, and I have a slider for the floats. This ensures that we cannot go beyond the maximum or minimum values. A Unity project should ideally feel like it's been developed by a single author, no matter how many developers actually work on it. A style guide can help unify your approach for creating a more cohesive code base. It's generally recommended to follow industry standards wherever possible. However, some projects have different needs. The key is that while there's more than one way to format Unity C# code, agreeing on a consistent code style for your project enables your team to develop a clean, readable, and scalable code base. Let's look at some general recommendations. Avoid variable names that are unclear, such as single letters or abbreviations. Ensure the names are descriptive and easy for all team members to understand. You could use camel case, Pascal case, or snake case when creating variable names, but be consistent throughout your project. For variable names, avoid using too many prefixes or special encoding. You could use an underscore for member variables, or M underscore, K underscore for constants, and S underscore for static variables, so the names reveal more about the variables. Methods perform actions, so their names could begin with a verb and add context as needed. For example, get direction, find target. You are aiming for clarity above all else. Every team member should be able to understand the code without ambiguity or confusion. For more tips, download our Code Style Guide ebook from the video description below. Object pooling is a technique which can improve memory management and minimize performance spikes significantly in your game. Using Unity's pooling class improves gameplay performance, for example when creating bullet prefabs. Instead of instantiating and destroying every bullet, it instantiates them once and adds them to a pool. Now they switch off when not needed and switch back on when needed. We can see this in the script. An object pool variable is declared. In the awake, the object pool is created. It then instantiates the object, adding it to the pool. Now instead of destroying the object, it is released back to the pool, and instead of instantiating a new object, it gets the object from the pool. Find out more about this in the object pool tutorial link in the video description below. Another quick tip to dramatically speed up the time of previewing your game in Unity is going to Edit, Project Settings, and in the Editor section, enable Play Mode options. Both Reload Domain and Reload Scene are both unchecked, so now it doesn't have to recompile every time you press play. Notice the scene now begins playing immediately. Unity Muse supercharges your project development. Solve challenging problems, get ideas for your project, and generate usable code through conversational AI chat that guides you on your creation process. I can ask Muse to generate a script by asking a question. I will ask how to dynamically create a box collider during runtime and double its size every time I press D. I tell Muse which version of Unity I'm using to get code specific to that version. After a few seconds of musing, it provides a script example and also a detailed explanation of how that script works. I can now use this example, modifying it slightly so it finds the correct object. During play mode, it works exactly as I wanted it to. Muse also flags potential performance issues, in this case increasing collider size during runtime, so it also guides you as well as providing a solution. Muse can also be used alongside the Unity documentation. So here I want more information on how the render state block works. Copy the code and ask Muse how this code works. Paste the code here and Muse now provides a detailed explanation of how it works step by step. You can also ask follow-up questions to add further clarification. Muse can also be used to improve your existing code. Here I have a script that destroys objects when they get within a certain range of my object. Muse has analysed the code and provided a more efficient version that helps to improve performance. Roslyn analyzers are tools that leverage the .NET compiler platform Roslyn to provide static code analysis directly within the IDE and is powering your IntelliSense. These analyzers examine your code as you write it, identifying potential issues, suggested improvements, and enforcing coding standards and best practices. You are probably already using it. Here it will add a missing namespace, or include a cast to convert a float to an integer. The red is the current code and the green is the recommended updated code, allowing you to preview the change before applying it. Or add a missing variable. It highlights errors in the code, making it quick and easy to spot and fix them. You can also highlight a set of commands and right-click to quickly extract a method or a local function to improve formatting and readability. You can also implement a new interface. Use the shortcut Ctrl-Shift-M for Windows or Command-Shift-M for Mac to open a list of methods and have the code auto-complete it for you. An efficient way to enforce code style rules across a large team is to set up an editor config file that ships with your project. To do this, in Visual Studio, go to Tools, Options, and under Text Editor, C# and Code Style General, click Generate Editor Config File Settings. This will now create the editor config file. Now under View, open Solution Explorer and go into Folder View. Double-click on the editor config file to be able to customize all the options which will be enforced when coding. For any option, you can change the severity levels. Under Tools, NuGet Package Manager and Manage NuGet Packages for Solution, you can search for more Roslyn Analyzer packages, or customize the ones you already have. To learn more, check out the Debugging with Roslyn Analyzers link in the video description below. Debugging is an important step during any project development. The debug class using debug log, etc. is useful. However, to create an effective debugging process, use the debugging workflows available in Visual Studio Code, Visual Studio, Rider, or whichever IDE you are using. In this example, I'm using Visual Studio. Breakpoints can be used in Visual Studio to check that the lines of code are performing correctly and in the right order. Clicking in the left section allows you to enter a breakpoint shown here in red. I want to check that this line of code runs when I move my mouse over a button. From the Debug menu, choose Start Debugging. In Unity, it attaches the debugger and asks if you want to enable debugging for this session. During play mode, it now stops playback when I move my mouse over the button, and it shows the line in Visual Studio. Click on the breakpoint again to remove it. I can do the same to check that the for loop is working correctly. Pressing continue will then skip to the next line and continue to run the code. The Locals tab at the bottom will also show any variables, so we can monitor how they are changing at that specific line in code. You can also attach conditional breakpoints by right-clicking in the right-hand section. I want to set a condition on this line to break if damage is equal to 100. Now it will only break when the damage is 100. Pressing the stop button will stop debugging and return Unity back to normal mode. For more debugging tips, check out the links in the description below. To strengthen your debugging workflow, you can also use assertions to validate assumptions about your code during development. This can be a great way to catch logical errors or unexpected conditions that could lead to bugs or crashes. You should focus on one assertion at a time. First, add a using assertions at the top. I want to check if damage is being set to 50 on collision. Check this using the assertor equal. 50 is what I expect, damage is what I will check. If they are not equal, I will leave a message to be displayed. I have also added a break, so it pauses the game immediately when the first projectile hits the wall. Now we see it in action. There are no messages because the assertion was correct. The damage is 50. When the game resumes, the second projectile hits and it displays a message because the damage is now 100. Assertions are a very useful way of testing that your code is producing the correct results. Testing in game development can quickly become repetitive and prone to error. The Unity Test Framework, however, offers you a way to automate your testing. Unity Test Framework (UTF) is available as a package in the Package Manager and allows you to test your project code in both edit and play modes. You can also target test code for various platforms such as standalone, iOS, or Android. To learn more, check out the link in the video description below. Unity provides you with a suite of tools that helps you prevent, identify, and fix performance problems. The Profiler, Memory Profiler, and the Profile Analyzer complement each other. Let's take a look at how and when to use each one. The Profiler can be opened from Window, Analysis, and Profiler. During playback, it records data. At any point, I can click in CPU usage and analyze frame performance in the timeline, which shows the frame completion time in milliseconds and all the thread processes that are taking place. This helps you to find ways to identify any potential issues and optimize gameplay. Profile Analyzer, which can be downloaded from the Package Manager, is used to compare the difference between before and after optimization across a range of frames to ensure the changes you are making are having a positive impact on performance. Memory usage can also be profiled by downloading the Memory Profiler from the Package Manager and gives a screenshot of memory usage at a specific point in your game. This is important to avoiding game crashes and ensuring the gameplay runs smoothly. To find out more about profiling, watch the tutorials on profiling. The links can be found in the video description below. Download the ebook found in the video description below for more great Unity tips. Thanks for watching.